So let's look at question 8. On question 8, we have this equilibrium. And our problem reads like this. Consider the following equilibrium. At 100 degrees, the reaction has an equilibrium constant of 2.2 times 10 to the negative 10. If 1 mole of COCl2 are placed in a 2-liter reaction vessel, what are the equilibrium concentrations for all of the molecules? So we have our ICE table. It says that we're starting with 1 mole in a 2-liter reaction, 1 divided by 2. That means our initial concentration is 0.5 molar. And we don't have any of our 2 products yet. We know that this one is going to lose X, and these 2 are going to gain X because our equilibrium is going to have to shift right to fill those voids. So at equilibrium, we have 0.50 minus X for our reactant and then X for our products. Our equilibrium expression is going to be carbon monoxide times chlorine gas divided by the COCl2 gas. So that when we plug those in, we get X squared over 0.5 minus X, and that is set equal to 2.2 times 10 to the negative 10th. Now, this is not one where we can just take a square root, right? Because the bottom value is not squared. But we do have a tiny k. So this is one of those times where we should be able to ignore X. Why can we ignore X on the bottom? Well, because our equilibrium constant is so tiny, we're going to make very little of our products. Remember that a very small equilibrium means it stays on the reactant side, and a very large equilibrium means it mostly moves to the product side. So this X value is going to be itty bitty. And compared to my 0.5, it should be almost negligible. So I'm going to walk you through the process of ignoring X and then proving that you were legitimate to ignore X. So the first thing that we'll do is kind of tweak this to ignore this. And I'll bring this down. X squared over 0.5 equals 2.2 times 10 to the negative 10th. See, I've just ignored that and brought it down. Now I'm going to multiply both sides by 0.5. So X squared is going to be equal to, should be 1.1 times 10 to the negative 10th, but let me double check. 2.2 times 10 to the negative 10th times 0.5. Indeed, 1.1 times 10 to the negative 10th. Now I can take a square root of this whole thing, and I will get that X equals 1.05 times 10 to the negative 5th. So that will be my concentration here. And if I subtract this from 0.5, I get 0.4999895. So to be honest, even when I subtract X, when I round for sig figs, I'm still at 0.500. And the first thing I can do is I can test to make sure that makes sense, like if it works and solves 2RK. So 1.05 times 10 to the negative 5th times times 1.05 times 10 to the negative fifth divided by 0.5 gives me 2.21 times 10 to the negative 10th. So that is to 2 sig figs. That actually plugs in perfectly. And then the other way that we test this is by something that we call the 5% rule. And what that means is that your X can't be more than 5% of your original concentration, or it can't change your original concentration more than 5%. So literally the way we do that is we take our X and we divide it by that original concentration and we multiply it by 100 to make it a percent. So 1.05 times 10 to the negative fifth divided by 0.5 times 100 gives us 0.0021%. So that one was perfectly fine to ignore. So that is question 8. We'll talk over the other questions for Le Chatelier's together. I hope that if you have used any of these videos that they were helpful, and I will see you in class.